Welcome to another class and the short session on TIFR problem solving. So this question that uh, we currently have in front of us, it's basically a question of to how to use Eisenstein's criterion. So the Eisenstein's criterion is something like this. Let us first see what Eisenstein's criterion is, and then we will understand how this becomes irreducible or reducible. Okay, so Eisenstein's criteria is, let's say, let Px belongs to Zx and Px equals to summation over ai x to the power I equals to 0 to n. Okay, so then if there exists q a prime number such that, first of all, q divides ai for all I in 0 to n. Okay, so it's basically I is less than or equals to 0 to n. Okay, so that means pi does not divide an. So it's like this, that q does not divide an, and the third part is q square does not divide a0. So if there exists such a polynomial with which has this criterions, that there exists such a prime such that these 1, 2, 3 properties hold, then Px is irreducible over Q and over Z. So this is the Eisenstein's criterion. Okay, so this is named as the Eisenstein's criterion. Okay, so how do we approach this problem if I want to look it from the Eisenstein's criterion perspective? So see, what you have is that the problem tells you that is this, let's say now your p of x is this 1 plus x square by 2 factorial plus dot 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 till x to the power 101 by 101 factorial. So is this irreducible in qx? So that means irreducible over q. So irreducibility in qx. So this is something that we have to check. So then, to apply the Eisenstein criterion, what is the necessary and sufficient condition that we can prove such that it shows us if it is irreducible over qx or not? So that necessary and sufficient condition is that 101 factorial into px is irreducible over q or not. So this is the sufficient, necessary and sufficient condition, because if it is 101 factorial px is irreducible over q, then dividing it by 101 factorial will also remain irreducible over q. Okay, so what is an irreducible polynomial? An irreducible polynomial, so fx is irreducible if and only if fx equals to some g1x into g2x implies either G1 or G2 is an unit. That means it has a multiplicative inverse. Okay, so that's what it means to be irreducible. And thus, if 101 factorial into Px is irreducible over Q or not, it is the necessary and sufficient condition to prove that P of x is irreducible over Q or not, because 101 1 by 101 factorial, it's always an unit in Q, right? So what is 101 factorial into Px? So it is something like this. So let's call this as some Qx. So Qx is practically x to the power 101 plus 101 x to the power 100 plus dot 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 dot. It will go on like this till 101 factorial, right? So now if you look at it, that 101 is a prime. All right. So what are my a0 to ai's? So is so n is practically 1. This is this one. So this is 1. The coefficient is 1. Apart from that, whatever the ai's you take, it is 101 into some integer. If you look at this, then the next one will be 101 into 1 into 100, and it will go on like that. Okay, so each of these ai's are of this form 101 into k. So thus now you can use the Eisenstein criterion, because every coefficient is an integer. So the moment every coefficient is an integer, so now this Q has become 101. So 101 divides all of these coefficients. That's the first property. Second is 101 does not divide 1, of course. The second property is also satisfied. And 101 square, it also does not divide the A0, that is the 101 factorial. So 101 does not divide 101 square, does not divide 101 factorial, because of the fact that 101 is a prime itself. So thus all these conditions are satisfied. Thus all these conditions are satisfied in this question, that it satisfies the Eisenstein's criterion. Hence, by Eisenstein's criterion, thus by Eisenstein's criterion, 101 factorial Px is irreducible in Qx. This implies Px is irreducible in Qx. Thus, this statement is true. So, one thing to be very careful about is the definition of the irreducibility. So, as you can see, fx is irreducible if and only if it is breaking into two factors, one of them has to be an unit. So 101 factorial Px and Px, what is the difference? So if this is my Qx, I have proved that Qx is irreducible over Q, right? So that means what? That means Px is nothing but 1 by 101 factorial into Qx. So this is your Px, right? So now this does not factor. So Px have only two factors, 1 by 101 factorial and Qx. Now this is something I have actually proved to be irreducible. Thus this does not factor in much more, and this is an unit in Q. That means it has a multiplicative inverse. Thus the entire polynomial is always irreducible. Okay, so that's for today. We will meet again with another problem. So this question is true. This is true. So this is a direct application of the Eisenstein's criterion and the definition of irreducible polynomial. So we will meet again next time. Till then, thank you for joining. Goodbye.